All right, tonight we're going over rectangles practice. So you should hopefully already have in your notes the properties of rectangles. And the properties of rectangles, they have all the same properties of parallelograms because rectangles are in the parallelogram family. They are parallelograms. But rectangles have those two extra specific properties where they have 4 right angles and their diagonals are congruent. So we'll use all of that information to solve some problems about rectangles. So let's start off with number 1, and they're going to give us a rectangle. I'm sorry, a rectangle. We're so used to talking about triangles, it's weird talking about rectangles right now. So we have P, Q, R, and S. All right, and they're going to tell us a couple things. They're also going to draw the diagonal PR along with the diagonal QS, and this intersection point we're going to call T. They're going to tell us that PQ is 24 and that PS is 10. And we're going to need to find a couple different things. Find QR, so the length of QR. We need to find SR, SQ, PR, and QT. So these are all asking for lengths of these segments. All right, so there's a couple things we could add to our picture. So we know that rectangles have 4 right angles, so we could certainly add that. Although I don't know if our right angles are really going to help us find these missing side lengths, but we can still add it. We know that rectangles have 2 pairs of congruent sides because they're parallelograms. So these 2 sides are congruent, that side's congruent to that side. And then they've also told us that our diagonals are congruent. So PR is the same distance as SQ. And then we know that T, the point where those diagonals bisect, or where they intersect, they bisect each other. So we also know that those parts are congruent. Okay, so looking at our picture, QR is the same as 10 because it's opposite sides. SR is the same as 24. SQ, well, SQ we know is the same as PR, but I don't know what either one of those is. So how could we figure this out? SQ, if we look at our rectangle is broken down into right triangles. So look at this right triangle, SRQ, and you can kind of redraw it if you need to. But SRQ, that's just half of that rectangle, and SQ is the hypotenuse of the rectangle, or the triangle. So we know that SR is 24, and we know that QR is 10. So if I know the 2 legs of a right triangle, how do I find the hypotenuse? I have to use the Pythagorean theorem. So I'm going to use my a squared plus b squared equals c squared, where these are my a and b. So 24 squared plus 10 squared is equal to c squared. So we can go ahead and calculate that. So we've got 576 plus 100 is equal to c squared. So 676 is equal to c squared. And lastly, to find c, we just take the square root of that. So take the square root of 676. And this is actually an integer, which is pretty nice. Take the square root, and we find that 26 equals c. So 26 is the length of our diagonal, or the length of SQ. Okay. If we know SQ is 26 and it's a diagonal, then PR is also a diagonal. It's going to be the same because that's that new property of rectangles. The diagonals are congruent. Lastly, they want to know QT. Well, QT is half of the diagonal, and we just said that that entire diagonal is 26, so it's going to be half of that, 13. Okay, so that's how we use properties to find missing pieces. Now we'll see some examples of angles. We're going to number this next example number 3. I know it's kind of weird to go from 1 to 3, but it'll make sense when we're back in class. So this one's number 3, and here's our picture. I've got a rectangle, and they tell us this is J, K, L, M. We've got diagonals JL and MK, and they tell us the intersecting point is N, and then they're also going to tell us that this angle is 27 degrees. And we're going to have to find a bunch of angles. We need to find the measure of angle MJK, the measure of angle MJL, the measure of angle JLK, measure of angle KML, and lastly the measure of angle MNL. Okay. So let's add what we know about this rectangle. Especially if I'm finding angles, I definitely want to pay attention to the fact that all 4 corners of a rectangle are a right angle. So if we know that that's a right angle, and I know that this much is 27, we can definitely figure out this remaining angle right here. If this is 90, I just do 90, take away 27 to find that remaining amount. So what should that be? So we get 63. So this is 63 degrees right there. Okay. One thing we know about rectangles is that their opposite sides are parallel. And anytime I have parallel lines and a transversal, something that intersects them, I should probably be thinking about corresponding angles, alternate interior angles. So if 27 is here, where else would 27 appear in our diagram? Well, let's look at our 2 parallel lines. 27 is created by this diagonal. If 27 is here, its alternate interior angle would be down here. So this angle will also be 27 degrees. That's helpful because now we know since this angle and this angle make 90 degrees, this must also be that 63 degrees. So our next step, we need to figure out the angles around M, the angles around K. Now, by looking at the picture, we could probably make a guess of what they are. They might be 27 and 63 again, but we need to actually understand why they are that. So remember, in any parallelogram, the bisectors, the diagonals bisect each other. Okay, so I've drawn my little tick marks to show that MN is congruent to NL and K is congruent to NJ. And this is important. I'm going to redraw this triangle, MNL. MNL. And let's look at what we just drew. What type of triangle is that in terms of sides? This is an isosceles triangle. Isosceles triangle. Okay. And that's helpful because in an isosceles triangle, it's got 2 congruent sides. And the properties of isosceles triangles tell us that the angles opposite of those congruent sides are also congruent. So we know in our triangle that this angle is 27 right there. So that must mean that this angle also is 27. So this is 27, and that supplementary angle over here is going to be 63. And then up at the top, that triangle JNK, since 27 is up here, this is also 27, again, because it's an isosceles triangle. And then lastly, this angle would be 63. So we're going to notice that we have a lot of the same angles repeating throughout the figure. And that's okay. I mean, this figure has a lot of symmetry to it. Those right angles make the diagonals congruent. It's going to have a lot of congruent parts. All right, so let's just answer these. MJK, MJK, MJK. Well, that's just one of the corners. That's 90 degrees. MJL. We found out that that's 63 degrees. JLK. JLK, we said that's 63 degrees. KML. KML, that's that 27 degrees. And then lastly, MNL. MNL, how could we find that one? MNL, so that's right here, 1, 2, 3. Well, let's look back at this little triangle we drew. What do we know a triangle is going to sum to? It's going to sum to 180. 180, not 188. We know that that's 27, and that's 27. So what? Let's find out. We're going to have 126 degrees remaining.